So if we import the OS module, we get a whole bunch of things, like get CWD, which stands for Get Current Working Directory, or chdir, which changes the current working directory. What's the current working directory? It's just whatever program Python is currently running in. I should say your script. Now, if you run your script from idle, then your current working directory is whatever directory your idle program is in. If you're running your program from something else like Notepad++, then your current working directory is another application, something else. So, well, let's create a script and just play with getting our current working directory, see if we understand what it's doing. So, Lecture K, file save as Lecture K. I also wanted to talk about threads, but I don't want to extend this to the point where we're not done with Chapter 4 this time. I really want us to be into Chapter 5, so maybe we're not going to talk about threads like I wanted to do. All right, let's find out what our current working directory is. dir is, well, we have to import the OS library, import OS, and then dir, well, that's a bad one to use because it lit up as purple. wdir for work directory, or cdir for current directory, is equal to os.getcwd, get cwd, parentheses in parentheses, and let's just print that out. Print cdir. It should be in the same directory that your Python file is located in, unless you're running this in a different mechanism than from idle. We can change that. Let's ask the user for a directory to change into, and then just change into that directory, right? cdir equals input, parentheses, quote, change to what dir, question mark, space, angle, just to display a cursor, end quote, in parentheses. And now let's change that directory. It's another method of the os module. os.chdir, and then pass in that variable. And now if we call getcwd and print it out again, in fact, I'm just going to copy those two lines. If I copy those two lines and paste them, I might put a print statement here saying that we just changed dir, changed directory, end quote, in parentheses. I put that above my new call to cdir, excuse me, to get cwd. All right, change to what dir? Well, I don't know. Let's do backslash. That'll take us to the root, right? So now we're at C:. We're the root of this. Now you may or may not know that if you enter a period as your directory that you're changing to, that just means current work directory, the current directory you're in. So it didn't change it. That is like if you're in a command prompt, like a so-called DOS window, and you do dir ... it shows you the directory listing of the user's directory, not the J. Thompson directory. It goes up a level. Now you see J.G. Thompson there. And if I do dir ... it's of the current directory. It's just a way to specify your current working directory so that if you're trying to get it, cd into it, if you're trying to specify something in it, you can just use a dot rather than have to type in a whole directory setting. You see that used more often in the Linux terminal is my recollection. For example, your search path. If I do set path, if you had a search path built and it had dot in it, then it would search your current directory as well as everything else for a command to execute. And in Windows, it goes ahead and searches your current directory for the file, as well as searching the search path. So we don't have to do that. But otherwise, we'd have to go in and we'd have to modify our path to include the dot directory to mean in whatever directory we're currently in. So when I run it, if I type dot, it just keeps us in the same directory we were in. And I could type the path to any other folder that I wanted to, right? If I'm in my downloads directory and I feel like, changing into that directory, I'm just copying that path by clicking in the address bar. And then if I run it, paste it. Well, that didn't work. Paste it again. All right. It changed the directory into it. So big deal. Well, now we can get a directory listing of that current working directory, just like we were in a command prompt and we did dir and we saw all the directories there, all the files. That one doesn't happen to have any files. So, I did not mean to open NetBeans. If we want a list of the directory, we call listdir and we pass in a path. So it's going to be os.listdir and we pass in a path. If we just do listdir parentheses quote dot, it's going to give us a directory of the current directory. It's going to give us a list of all the files in the current directory. Like if we were in a command prompt and I did dir dot, it shows us all the files in the current directory. So that sounds plausible. Let's go ahead and do that. Please go away. So listing for file list, but it also includes a list of directories, so I'm not going to call it file list. Listing equals os.dir list parentheses quote dot end quote in parentheses. Kind of looks like a very surprised looking little animal there or something like that. Make sure that I have the syntax for that correct. Listdir. That's what I have, right? I have dir list. Okay, I got it exactly backwards. Change that to listdir. And now we can print that out. It's a list, just like any other list. So print the listing. All right, and there's a list of all the files in that current working directory. I have a PowerPoint, and I have some py files, and some other weird things. I don't know what those numbers are, but they are files in it. I guess I was just typing things in at random while we were creating files to write to. Random.txt, stuff like all that. Surprised not to see an import.txt file. I thought that we had played with importing into Excel. Had we done that?
Yes, we did.
All right. Interesting. I don't see it. Must still be there. Well, that's a lousy way to present the information. We might instead want a for loop that'll print through the list. And printing through a list with a for loop is just as easy as using a for loop to go through a series, a range. So for file in listing, it's not really a file. How about for entry? Or even E, whatever. Print parentheses E. All right, and there it is in a better format, right? Everything that's in that directory. Each file has a statistics block saying when the file was modified, when it was created, whether it's a file or a directory, that kind of stuff. And we can get that statistics block, a stat block for it. And I'm not seeing it. Maybe it's on the next page. Well, this would work. We'll use os.path. So let's check to see if the thing that we're looking at is either a directory or is a file. And we're going to do that by using the os.path object. So I'm going to comment that out for now. And I'm going to do if os.path, did I get that right? My brain is so, yeah, os.path.isFile, parentheses, and then pass that file name into it, E. Then we're going to print, parentheses, quote, file, end quote, comma, E, the file name. I'm kind of not liking seeing E there. I'm going to go back and just change that to file name everywhere that appears in this little loop. It's not that much more typing. We know how to type in file name. Makes it a little less terse. Else, or elif, os.path.isdir, parentheses, file name, in parentheses, colon. Let's parentheses, quote, dir. And I'm just going to put a space so they line up perfectly, right? Because this one's 4 letters long. I'd like for this one to be 4 letters long too. So space, end quote, comma, file name. And if neither one of those is true, I don't know what it is, right? If it's not a file or a directory, what the heck is it? So else colon, parentheses, quote, and then how about 4 question marks? It shouldn't do that. I don't expect to see that at all. But anytime you have a dangling else, it's not a bad idea to go ahead and handle that case. Alright, so change to what dir? Yeah, just dot again. And all of these are files except for there are a couple of directories. I had a directory called CIT1203 for some reason in that. Not any at all, hardly any at all. So I'm going to run it again and I'm going to enter C:/ as my current directory. C:/ or just a slash. And there it goes. Right, now we have all sorts of directories and files. All right, apparently I really thought it was in the PowerPoint, but it's not getting the file size. Surely it's in here. Oh, it's right there. That is a completely different way than how I was doing it, which is to get a stat block for that particular file entry. Let me see what I'm thinking. Get stat Python file. So you can call OSStat, or nah, we're not going to even mess with that. We're not going to even mess with it. We're just going to do the way that they suggest. So why don't we get the file size for that file? If it is a file, right? If it's not a file, I'm not going to try to get the file size of it. So file size equals os.path.getSize, I believe. Let's look it up. Get size, and then let's pass in our file name as a parameter to os.path.getSize. And we can add that to the stuff we print out. Now at this point we ought to be using a formatted print with %s's and stuff like that, but let's just print it out like this. File size, comma, quote, bytes. It's not going to be lined up nicely, and if we wanted to line it up nicely, we could do so. We would just change it to a formatted print. So, all right, there we go. And we can see file size. Camtasia.msi, the installer for the program that I use, is pretty large. 2 gigabytes or maybe even longer. I don't know. 1, 2, 3, 4, 5, 6, 7, 8. It's 287 megabytes, whatever. Page file is absolutely huge. All right, so you can use os.stat to get statistics about a file. And then st_size is one of those statistics. What else is there? os.stat Python. I might be able to get some help about it just by going to my shell and doing import os and then doing dir os.stat like that. I'm not seeing a lot of help there, a lot of stuff. So let's do help parentheses os.stat. All right, gives us some information, not a whole lot about it. Performs a stat system call on the given path where we can get some information. Get some information out of it. This is not telling us what the name of the variables are, the attributes that we could use. So if you call the stat block, or if you get a stat block, you can check to see if it's a directory. You can check to see if it's from a block special device file. I don't know what that is. You can check to see if it's a regular file. All right, sounds good to me. If it's a symbolic link, and a symbolic link is a way that you can embed a directory link inside of another directory, so you can change it into a directory that was not actually part of that hierarchy, that was not a part of the subdirectory. I'm not seeing anything else except for the file size that I'd really want to play with. So, not going to mess with it. We already have ways of getting the file size and whether it's a file or a directory, so I don't think we need that. So I don't know why I taught the other class to do it that way. All right, so we have something that will get us all that information. Now what if we wanted to make a list that had all that information in it? We could do so. We could create a list where every item in the list was a tuple that had the file and the file size. And we might not add anything if it was a directory. I'm not going to do that, but we could. All right, so now we have enough information to know how to change directories, get our current working directory, open something, or check to see if it's something to open. We could pick one of these files and then allow the user to open it. Right, we could ask them for the input file name and then, and then open that file and read out the contents if it was a text file, something like that. I feel like messing with this just a little bit to only display txt files and py files. So I'm going to do that in a second in a subsequent loop. For file name in listing, if it's a file, so if os.path.isFile parentheses file name colon if .txt end quote in space file name or parentheses, or quote dot py end quote in file name, then it's a Python file. Or we could open it. It's a text file. So let's do print parentheses file name comma quote is a text file or is an ASCII file. End quote in parentheses. Now I'm not going to even print out any other information except for those cases. All right, and it found some text files. So if I then had a question, or if I wanted to, I could let the user type in a file name based on that, and they would have a good chance of knowing that they were opening a text file for whatever purposes. Anybody have any typos right now that they really wish I'd be looking at? Alrighty. Uno momento. So, OS library Python. If we go and look, did I already cover this? We can get environment variables from it. We have change directories, get current working directories. We ought to be able to get the version of Python, get a specific path, get an environment variable from it. I'm not seeing anything that's super exciting for what we're trying to do right now. Get login, what is that? Return the name of the user logged in. That sounds fun. I'm just going to print out the name of the current user logged in up at the very top of my program, see if that works, right? Print, parentheses, os.getLogin. Just curious. Curious as to whether that'll work. Yep, that's my login name, J.G. Thompson. Get our priority, what progress level we're running at. Excuse me, process level. And there's a lot of stuff in there that's looking like nothing I want to play with. Alrighty. Okay, let's switch over and talk about the projects. And if you're in another one of my classes, I'd like you to do a different project for this class than you were doing in the other, rather than just say, okay, I'm going to do the same project in C++ and in Python. I'd rather you try two different things, unless you can really convince me otherwise. So there's going to be 4 directories. You know, one for the 21st, one for the 28th, one for the 5th, and one for the 12th, so that you can upload in temporary versions of it, right? You make some progress over the next week, upload something into it. You make some more progress, upload something into that. That's just to keep you, working on it rather than, because if you're skipping uploading things in it, then I know that you're putting off working on it, and you're going to wait until the last week, and I really don't want you to do that. Alrighty, so the word and letter count. This one is not too bad. You might want to choose this one if, well, I won't prejudice you. Let's get it open. Your program will open a text file and print a table of how many times each word appears in the file. Also, print a table of how many times each letter appears in the file. And I don't know why the word data is there. Okay. And in my opinion, the project would best be written with dictionaries. One of the reasons I want to talk about dictionaries today, so you can start working on it if you wanted to. So what's the program going to do? Ask for a file name, open it for reading. The file that it's reading should be a text file containing a paragraph or more of text. Yeah, apparently I can't spell. The program will process the file to create a count of how many times each word appears in the file. And the program should also create a count of how many times each letter appears in the file. And the output display the word counts and then the letter counts. So, examples. Hints. Strongly consider using a dictionary for the word count and another for the letter count. You could use lists, but it'd be a lot more work. Alright, so like this. It opens the file, it read it all, and it figured out that the word the appears. Well, these don't seem to be in any particular order, are they? Well, how come the word the doesn't appear in it? What kind of text file could it that doesn't it? Anyways, so I don't know what text file this was, but again appears once in it. The word are appears 3 times in it. The word and appears 3 times in it. And of course, the longer the text file, both the more words there are and the more counts, right, for duplicate words, right? 4 times does the word no appear in it. And then for letter count. In this file, there were 31 A's, there were 33 E's, there were 25 N's, and so on. So, I suggest that one. That's a good project. It's comprehensible, especially once we talk about dictionaries, which we will do next. Hangman. Hangman is a common project because it's very easy to understand. We have all played Hangman. The drawback to Hangman is that every semester I have at least one person, probably 2, who goes and downloads a version of Hangman from the internet and turns it in. And I can tell if you did that. So this very strongly, emphatically worded note. Note, you will fail the class if you turn in a Hangman program you downloaded from the internet. I can tell if you did. Don't try to fake me. This is academic dishonesty. I mention that because each semester at least one person does that. Let's not this time. So if you get stuck, don't download it from the internet. I'll give you a design document that'll make it easy to implement. So this is a good project for if you get totally stuck on another one and you only have 2 weeks left and you really want to crank out a project, right? You could ask me for help. You could ask for the design document and it'll make it a lot easier. Or do it completely on your own. Don't wait that long. So let's play Hangman. I'm thinking of a word. It's 7 letters long. Guess a letter. All right. Guess an A. Correct. Guess a B. Incorrect. You can only make 7 more mistakes. Guess a C. Incorrect. Guess a G. All right. Correct. There it is so far. Guess N. Correct. Guess a letter D. Incorrect. You can only make 5 mistakes. All right. And we can kind of see where it's going, right? It'd be kind of nice if, like on Jeopardy, the other game show that you see with Vanna White. Yeah, Wheel of Fortune, where you could say, okay, I can guess the word, right? But instead, we're making them guess every single word. All right. You don't have to make yours look exactly like this. When I wrote it, this is how mine wound up looking like. Deciphering a substitution cipher. Now, since our book comes with code for a Caesar cipher, this would be a little bit of a variation for it. Not a Caesar cipher per se. You'll write a program that attempts to decipher a text file I give you. So if you want to do this one, ask me for the text file. So I'll give you a file that's encrypted with Caesar cipher or another method. You don't know how. You don't know what method I did. And you'll break the code by using an ordered list of the most common letters in the text. So I'm going to provide you with both this list, which is the most common letters in the text, which is going to be customized for each file. And in the English language, more spaces appear than anything else. And then in this file, there were more E's than A's, and there were more A's than S's. And so if you built a list, a string of the most common letters that appear in it, it might look like this in the encoded text. And then you could go, well, I'm going to replace every exclamation point with a space. I'm going to replace every S with an E. I'm going to replace every B with an A. And if you look at it as a Caesar cipher, everything is just shifted by 1, right? F is an E and B is an A or whatever. But you don't have to actually figure out what the cipher is. You just need to do this substitution. And after you've done so, then you'll get something that looks like English text, even if you can't read it all, right? Chapter odd creates this earth, and it's right. So we're pretty sure that we're on the right track if we do that. And so one of the things that cryptologists do is when they're trying to crack a code, they have giant lists of words and their frequencies, right? The word D appears this more often than anything else. And, these words commonly follow each other and that kind of stuff. And so this is just kind of going in that direction. If you're going to work on this one, let me know. So pretty quickly I can give you the file and the decryption key. Pardon me? You want that one? Okay. Would you send me email so I'll remember to do that? All right. I think that one's a fun one. Mastermind. You may have played Mastermind as a kid. Nowadays you can download Mastermind apps for your phone. Right? The idea behind Mastermind is that, you have the dungeon master on this side and you have the poor player on this side. I don't know what he's called, the referee or whatever. Right? And he sets up this code, she sets up this code on this side, and the player's trying to match. So our code is black, red, yellow, and blue, green, whatever that's supposed to be, green. And so the first guess a person makes is white, I can't read this color, white, blue, green, and black. And it turns out that some of those colors are right and some are wrong. There is a black one, and there is a green one, but there's no blue one, and there is a yellow one. So they got 3 right. I have to be looking at this wrong. Black, black, green, green. Okay, but there's no blue and there's no white. So they get 2 white pegs showing that you got 2 colors right, but you don't have their places correct. So they make another guess. And in that row, they only got 1 color right. And none of them were in the correct place. And eventually they start making guesses where some of them are in the right place. At this time they guessed, guys at home can't see me gesturing, black, red, white, blue, and the black one's in the right place and the red one's in the right place, so they got 2 black pegs and no white ones, right? And then eventually they get it all right. And I guess the number of turns is limited by the length of the board. I don't care if we implemented a maximum number of turns or not. So instead of colors, why don't we just use numbers? So I'm thinking of a secret code. The computer goes and he actually picks 5, 4, 3, 2. So my first guess is 1, 2, 3, 4. Well, if I look, is a 1? No, there's no 1. Is there a 2? Yeah, there's a 2, but it's in the wrong place. Is there 3? Yep, it's in the right place. Is there 4? Yeah, but it's in the wrong place. So we got 1 correct. 2 of them were misplaced. So here's kind of a brute force fashion. We could just pick all 1s and all 2s and all 3s and all 4s and all 5s and get a count, right, of how many were, in there. So we tried that. All 1s. Nope, none of them were right. So we know that our answer doesn't have any 1s in it. So now we guess 2, 1, 1, 2. Well, that's stupid. Why would you do that? Well, because it rules out the middle 2, right? We already know that there's no 1s in it. So now we're checking to see if either one of these is a 2. And we find out, is it right? 2, 1, 1, 2. That's wrong. And I'm going to have to fix that. All right? So there were 1 misplaced and none correct, if I'm eyeballing this correctly. 2, 1, 1, 2. No, there is 1 in the correct place, right? 2, 1, 1, 2, and it ends with a 2. So yeah, there's 1 in the right place. And so more about round 3. Be careful how you handle mismatch duplicate digits. When I guess 2, 1, 1, 2, that one plugged into place, that 2. And then the rest of it, there are no other 2s. So I don't want to say, oh, by the way, there's a 2 in the wrong place and there's a 2 that's correct. Really, there's only 1 2, and so it can either be correct or it's in the wrong place. And so I give you a sample program, how I wrote it. You don't have to make yours look exactly like that. If you want additional help on learning how to play Mastermind, just download a Mastermind app or play it online. Lots of people have written Mastermind games. Pie Fighter. Now this one has an insanely long instruction document. It's not as hard as the document makes it look, but each year people ask for more explanation, and so I added more to the document until, looks like the federal budget or something like that. So, it's a game where you create statistics, attributes for 2 fighters, Fighter 1 and Fighter 2. And so eventually in here I create Thor versus Trogdor or something like that. So the way it works is that every fighter has a name, every fighter has a combat rating, every fighter has an armor, I don't know why I put an S there, and every fighter has a certain number of attack dice. And they use these to attack each other. If you're familiar with playing fantasy role-playing games at the desktop like Pathfinder or Dungeons and Dragons, then you know the idea. If you're familiar with role-playing games like Final Fantasy, old school games, you know the idea of hit points and stuff like that. And so in this case, the combat rating serves as their hit points. So the name is their name. The combat rating is the health of the fighter. When it drops to 0 below, the fighter is defeated. Attack dice is how many dice they get to roll to attack. And then the army is how much gets absorbed. So each one rolls, like, say each one had 3 or 2 dice, 2 attack dice, and one person rolled a 10 and the other person rolled a 2. Well, the difference between 10 and 2 is 8. So the loser's going to take 8 points of damage. But if they have some armor, like if they have an armor with 4 points, then it would be 8 minus 4. And that person would only take 4 hits because the other 4 were absorbed by their armor. And then the rest of this is a re-explanation of the rules. And then the next page is a very careful explanation of the rules. You determine your attacks. The only thing that I didn't mention is that you get an attack bonus based on 1/2 of your health. So like if you have a health of 20, you get to add 10 to your dice rolls. If you have a health of 10, you get to add 5 to it. So Conan rolled a 22, and he has a health that gives him a 5 bonus, and he rolled a 27. And the other dude rolled it up, and he got a 32. So 32 minus 27 is 5. Conan's going to take 5 points. However, his armor is 2. So 5 minus 2 is 3. So he takes 3 actual points. And then it just keeps repeating. Now the only complication is that if the armor is too good, right, if you set their armor equal to 100, they're not going to take any hits. And it'll run infinitely, and I ask you to stop that somehow. Give some thought as to how to do that. Maybe you reduce their armor, minimum damage assigned, or every time somebody takes a hit, it reduces their armor by 1 or something. You can figure it out. I give some ideas for that. Lots of people like that one if they're into like fantasy role-playing games or whatever. And some people change it to a space theme, right? You got 2 spaceships fighting each other. And good old Caesar's Cipher. And since, like I said, we have Caesar's Cipher already in the book, I'm going to want you to implement another mode of it too. So we already have the idea of Caesar's Cipher, I believe. What you're going to do is you're going to enter some text, or the user's going to enter some text and a shift value. I want a shift value of 3, whether to encipher or decipher. And then how do you want to do it? A modern Caesar's Cipher or a modified Caesar's Cipher? Well, why is it called modern? Because Julius Caesar didn't have ASCII characters and have to worry about number signs and things like that. So, since the code gives you the source code to do a simple Caesar's Cipher, did I spell cipher wrong? Yeah, I did. Apparently my version of Word is not flagging on my typos. I need to fix that. Okay. So an explanation. Yeah, we know what a Caesar's Cipher is. A could become a D, and a B could become an E, and a C could become an F, so on. And so return to Rome could turn into that. Now this is a really primitive one, and it's not changing the spaces to anything else, and ours will. Because we'll shift the space to something else as well, along with every other character. So a modern style using ASCII, where we use the ASCII values. So an A, if our shift value was 10, would become a K, because a 65 becomes a 75. And a B would turn into a 76, because a 66 plus 10 is a 76, and it'd turn into an L. I said B. A C would become an M, because that's 10 characters higher. A space would become a 40, would become a star, because that's 10 higher, and so on. And then if you were going to decrypt it, instead you subtract 10 from every character. So if your encrypted text looks like that, and then you subtract 10 from every character with some wraparound, then you get A, B, C, X, Y, Z, which was the original value. The modified one makes it so that if you start off with a shift value of 10, the second character is shifted by 11. The third character is shifted by 12. The fourth character is shifted by 13. The fifth character is shifted by 14. Right? You can just see that the shift value adds 1 each time, so that it scrambles the text significantly more. It'd be far more difficult for somebody just eyeballing it, trying to figure out, oh, I know this is a Caesar cipher. They'd be completely stumped. Again, it'd take the NSA about 0.1 nanoseconds to solve it, because they're not encrypted. They're just enciphered with simple substitution ciphers. All right. I think that one's a very doable project. What's left? Are we done? All right, and we're done. Project guidelines. Alrighty, I want to go to the next PowerPoint. Start talking about lists and directories. Dictionaries, especially dictionaries. As a matter of fact, I don't even want to take the time to open the PowerPoint because I can show y'all lists better than they can. Alright, I'm going to declare a list, and I've done this before, and you've taken maybe programming courses before where you declare lists. Alright, so we're going to make a list that has 3 names in it. Bob, Fred, and Sam. With quotes around them, all separated by commas. If I want the length of the list, X is equal to len parentheses L. Gets the length of the list. If I want to see if something is in the list, if quote Bob, end quote, in L colon, print parentheses quote, I found Bob. Else colon, print, no Bob found. Now lists are accessible, addressable by their index value. That's index value 0, that's index value 1, that's index value 2. So if I want to change Sam to somebody else, Frodo, poor Samwise is taking a vacation, we're subbing in Frodo. L subscript 2, 0, 1, and 2 is now equal to Frodo. And we can print our list out. Here's the easiest way of printing it, and it's a lame way. Print my list out. Nah, that's lame. Why is it lame? It's just going to put however Python likes to format lists. Right. .t is a ASCII. All right, I found Bob, and there's how it printed the list. That's kind of lame. We can come up with better ways of doing that. One way is to use a for loop. Like this. For space name, for space name in L colon, print name. That'll print it all one per line. We could gussy it up a little bit and print them all on the same line using the end parameter of the print statement. For name in L colon, print parentheses, name, comma, end equals, quote, space, quote, in parentheses. So print a name with a space after each name. Not going to the next line. So when we are done with our for loop, then we better print, a character chart. Go to the next line. Or else we just leave our cursor hanging out at the end of a line. All right, and so that's how it worked the first time. It printed out one per line. Here's how it did it the second time. It printed out Bob, Fred, and Frodo. And now we're going to do the all fancy, hyper awesome way of doing it, which I don't care if you memorize. I'm not going to ask about it, but it's useful. Print parentheses, pound sign. What do we want everything separated by? A comma? Yeah, sure, why not? Comma and a space? Yeah, cool. And then dot join, parentheses, name. Now that should have been inside of, nope, that's not the name of our list. Our list is named L. So dot join, parentheses, L, in parentheses, in parentheses. Now when this runs, see what it did? It printed out the list, but every name is separated by a comma. Well, couldn't you have done that with the end parameter? Could have. I could put a comma there, but look at the difference. That time it put a comma at the end. And yeah, we could add some extra logic to get it to avoid that, but if we can print it out in one step like that, then that's good. And heck, now that we have a string with it separated by commas, we could use dot split or something like that in order to get it back out. So I'm going to change this back to just being a space. So that's what a list is. What if you're a Java or a C++ program and you really wish you had arrays rather than lists? Well, Python doesn't support arrays. It only supports lists. What's the difference? An array is fixed length. You declare an array of 100 elements, it's always going to be 100 elements. You can't append something, you can't delete from the first of it and have it resize, whereas a list you can. A list you can append with it with reckless abandon. But here's how you would declare an array in this language, just for those who might ever want to play with an array. AR is equal to, let's make an array of 100 ints. 100 times square 0 in square. And then if we print out our array, okay, 100 is a little bit too much. Let's make an array of 20 ints. 20 star subscript 0 in the subscript. And then when we run it out, we see that it is in fact a list. It still is a list. And anything in Python that you can normally do with a list, you still can do with it. It's not fixed in length like it would be if you declared it in C or Java or something like that. But create an array type list is all I'm going to say. And then I'm going to say Python doesn't support pure arrays. Lists are more flexible, so that's why the guy who invented it skipped implementing it. You can get lists in those languages that do support arrays. In Java, it's called an array list. In C, C++, it's called a vector, and so on. So what if we want to add things? You want to let the user type in some scores into a list. Well, we can do that. What if we need 3 numbers to average for whatever purpose? Well, let's declare an empty list. Nums equals, and that declares an empty list right there. I believe you could also do it like this, nums equals list parentheses in parentheses. I think that would also work, and it makes it a little bit clearer. On the other hand, this is so common that that's how pretty much every Python programmer would do it. And then let's just write a little loop that'll run like maybe 3 times. For I in range 3, colon, let's get a value, right? X equals input, quote, enter a score, angle, end quote, in parentheses, and let's add it to our list. Nums.append X. And let's just add some debug information to this. Print parentheses, quote, the length of the list is now, end quote, comma, len, parentheses, nums, in parentheses, in parentheses. You don't need that, right? It's just going to be for curiosity's sake. And why don't we print the list itself out? Then we'll probably comment these things out. So print nums. I better stop. I better slow down. But I want to make sure it works. All right, enter a score. 100. The length of the list is now 1. It was 0. It now has 1 element in it. 90. The length of the list is now 2. 100.90. And then they make a 30. 190.30. And so with that, we could get the sum of the list and calculate the average. Total equals sum, parentheses, nums, in parentheses, average equals total, divided by, or slash, len, parentheses, nums. And we can print them out after we understand the way that works. I think I'm going to comment those 2 print statements out just because they kind of clutter it up. Let's pause. Okay, guys, I made a goof because what they entered was strings, and then sum is expecting ints or floats. 2 ways we could fix that. One is we could just convert it to a float right here. Now, we could say x equals float, parentheses x, like we always do. That's probably the best way. Or the other is that we could have used list comprehension to convert it. I'll put that as a comment since we did it the more normal way there. We could have done this. Total equals, and in square brackets, float, parentheses, x, for x in nums, in square. That would take every element in the nums list, turn it into a float, and then store it back. What? Not total equals. Nums equals float x for x in nums. Just turns every string in it to a float. Either way would work. If we had read this from a text file, the data would come in as text. And if we called .split, we'd still have strings. And so eventually, at some point, we might want to use list comprehension to convert them into all floats, or we might want to step through it, changing them like that individually. say print total equals comma total and print average equals. Let's run it again. All right, now some numbers. Yeah. All right. And we could have printed out the total and the average of the bonds if we wanted to. It would need to go at the end, and I had it commented out, which is an example, but you could cut that out and put another 4. Instead, we need numbers equals or square brackets, all that stuff. Yeah, but it's not going to work because we're not doing this step. Either uncomment this line or add x equals float x to it. That'll fix it. And this is more like how we normally do it, right? X equals float, parentheses, input, enter a score. That would have done it. Don't know why I forgot. All right, so our homework based on this concept, on this stuff. You will create a list of names. Ask the user how many names to put in the list. Then loop that many times, appending each name they input to the quote names end quote list. Then print the list out. Print the list out with the syntax a for loop syntax. For S in names, right? Print names, print S. Something like that. That's part of it. Secondly, create a list that is 100 elements long. Each item in the list is equal to the square of its subscript. So, element 0 will have the value 0. Element 1 will have the value 1, right? Element 2, it's a square, will have the value 4. One more. Element 3 will have the value 9, and so on. And so since it's 100 elements long, it's going to count from 0 to 99. I don't know what 99 squared is. We'll find out. Python shell 99 power 2 is 9801. So element 99 will have the value, and I've already forgotten, 9, where did you go? $9,801. What I would do, create an empty list and append the values. 1 squared, 2 squared, 4 squared, so, or 0, 1, 2, 3 squared, and so on, using a for loop. For I in range, not to make it too easy, but I just did, for I in range 100, loop, that kind of thing. Have we talked about removing an item from a list yet, or searching the list besides just checking with the IN keyword, like how to remove every element that equals Fred? Okay. That's the kind of stuff that we'll hit next lecture. So homework makes sense. All right, I'm going to talk about dictionaries for 7 seconds and then stop about it. Wouldn't it be neat if instead of something like this, names or age subscript 0 is equal to 35, age subscript 1 is equal to something, wouldn't it be neat if we could do this? The age of the person named Fred is equal to 35, and the age of the person named Sue is equal to 45. And you can do that. That's called a dictionary. Why is it called a dictionary? Because what if your dictionary looked like this? Spanish to English dictionary, hola is equal to hello, right? Like that. In Spanish to English, right, gracias is equal to thanks. Like that. So what we are doing is we're establishing a relationship between keys and values. So let's make an empty dictionary, if you've been typing along, so that you could do this. Age is equal to DICT, parentheses, in parentheses. That's one way to declare an empty dictionary. Here's the other way. Just like I showed you 2 ways of creating an empty list. SE equals, and then 2 curly braces creates an empty dictionary. And now I can print out Fred and find out that Fred is 35. Print age subscript quote Fred, end quote, in subscript in parentheses, and I could find out what Ola's translation is. Print parentheses SE subscript quote Ola, end quote, in subscript in parentheses. And so when it runs, hopefully it'll say 35 followed by hello, because those are those values according to our dictionaries. Other languages call them different things. In Java, they're called maps, hash maps, and sorted maps. And it did. It worked. So that's the idea behind a dictionary. But dictionaries can be used. You could store in your dictionary a number, and then later on you could increase that number, right? And then later on you could increase that number again. So you could do something like this. Age, parentheses, quote, Sue, end quote, end brace, equals age subscript, quote, Sue, end quote, plus 1, right? And if you repeated that over and over, then Sue's value would first equal 45, and then it would equal 46, and it would equal 47, and it would equal 48, and so on. And so that would work for your letter count. You could step through some text using each letter you find as the key, and then the count would be the value, and each time you find another occurrence of it, you just add 1 to it. So increment the value associated with the Sue key by 1. And let's stop and make our drop boxes and stuff. Of course, I never ran it. Well, I guess I did run it. Changed to what dir, whatever. All right, worked. I'm going to print out Sue rather than Fred down here because I modified the Sue, and I want to make sure that it actually equals 46 rather than 45. And it came out 46. Okay, so that worked. We will certainly talk more about dictionaries, and you could read the PowerPoint, and you could read the text. I'd go ahead and do that. At this point, lists should be somewhat of a review, especially for the people who took fundamentals. Dictionaries may be a brand new topic. Who took fundamentals and learned about dictionaries? Who took fundamentals and did not learn about dictionaries? All right, so good, because I don't want to teach something that every single person knows. All right, let's stop. Make a Dropbox.